Hello, everyone, and welcome to today's webinar on the highest performing onboard charging for non-road mobile machinery. Today's webinar is 1 hour long with 45 minutes of presentation time and a 15-minute live Q&A session at the end. If you are not familiar with Delta-Q Technologies, we are a leading battery charger manufacturer for lead-acid and lithium-ion batteries and a Zappi Group company. Should you have any questions throughout the webinar, please use the chat function to submit your questions, and we'll be able to answer them at the end. My name is Akanksha, and I'm the Content Marketing Manager here at Delta-Q Technologies, and today's webinar moderator. Joining us today is Mourad Chergui, Delta-Q Senior Product Manager, and today's webinar speaker. Mourad has been with Delta-Q since 2016, and he has over 25 years of experience in product management. At Delta-Q, Mourad spearheads new product strategies across vehicle electrification, power conversion, battery charging, and regulatory standards. Today's session is part one of our three-part webinar series. Today's session will be discussed by Mourad in the next slide. Part two will be on April 5th, 2023 at 8 a.m. Pacific time, 11 a.m. Eastern time, and 5 p.m. Central European time. We will be discussing how to design compact electric machines for the toughest environments. Part three will take place in May during Zappi Group's Future of Electrification conference, and we will be discussing high voltage charging solutions for non-road mobile machinery. If you're interested in attending part two or part three, we will be sending you the registration link along with today's presentation slides and today's webinar recording in our follow-up email. I will now be passing it to Mourad to start today's session.
Thank you, Akanksha. Good morning, good afternoon, everyone. Today we'll be covering several topics that are related to non-road machinery vehicles electrifications and more particular charging solutions. And we will focus the presentation about the concept of a 3-in-1 charging solutions. The presentation is actually cover different evolution in this field, and we'll start from what we would consider the beginning, which is the period actually in the last 3 decades. So electrification, or more particularly vehicle electrifications and batteries, are not new. They date back actually from the 1830s. That's where automotive and several applications start using some electric cars. And as you can see in the left picture, this is a system and a practical car that was invented by Thomas Parker in about 1884. And on the right photo, you can see an early example of an off-board battery charger that was called Watt Station, and it was developed around 1910. Since then, the industry keep innovating and adopting electrifications, but truly it's not until the 1990s that this electrification become widespread and mainstream. It became mainstream first in the automotive market, but also some other applications, especially related to industrial and commercial vehicles, started engaging, and nowadays almost all the vehicles in these markets are electric. This the main driver for the electrification during this period from the 1990s to 2020 was, the first one was the comfort of the driver and the people surrounding the vehicle by reducing the noise and the vibration. And this is especially true for golf cars. The second and more important feature that push for electrification is actually machines working in indoor environment. And thus, by that, it requires eliminations of carbon monoxide, toxic materials, and fume due to the combustion engine running indoors. So electrification was the natural choice. And nowadays, in these particular markets, golf car and people movers, commercial floor scrubbers, scissor lifts in construction equipment or renovation, and material handling, electrification is predominant. With electrifications comes the need to charge the batteries that are on board the vehicle. So the requirements there for onboard chargers is to charge mainly lead acid batteries during this period. The voltages ranges from 24, 36 to 48 volt nominals. The required charge time was about 8 to 12 hours, which is actually suitable for doing the charging overnight when the vehicle is not used, so that it's ready for the next day. And the charging power ranges from 300 watts to 1,000 watts. Important to note that for this type of chargers, the power source was typically the residential AC outlet. In North America, this is the 120 volt 50 amp NEMA connector, and in Europe, it was the voltage 230 with the maximum current of 10 to 16 amps. So this is the and that's also apply to also other places outside North America. It is important to note that with this type of outlets, or the residential outlet, the net charging power available to charge the battery is a maximum of 1,200 watts, and that's why the chargers ranged from 300 to 1,000 watts. For any more power, people or applications were using off-board chargers. And to support these different applications, there have been development of low voltage, low power onboard charging solutions. And we saw innovations coming in the forms of ruggedness, because the vibration and the shocks that are involved in this type of small vehicles, the charger needed to be sealed to prevent liquid cooled to prevent liquids and dust to come into the charger. This charger also would have to comply with various certifications depending on the region of the world. We saw also innovations in terms of high frequency chargers and the emergence of digital power control and smart communications. So smart communications with typically with other parts of the vehicle. These OEMs, now becoming a more and more sophisticated and large, required suppliers of components to have scalable manufacturing and also quality products and processes. An important feature of this product is the configurability and optimizing the charging for lead acid and then later on lithium ion battery packs. So now we go to another era in this in these applications, which have pushed for the electrification of compact mobile machinery. Sensing the need for reducing the effect of climate change and pollution, several governments have enabled legislations to curb the emissions from combustion engines and other sources. One notable legislation, which is actually known as Stage 5 in Europe, it was a very crucial legislation that came into effect in 2019. Before that, there was lower standards because it actually went through stages from 1 to 4. So the requirements were lower, and also it didn't cover any vehicles or any engine below 19 kilowatt. But starting in 2019, the range of motors or engines covered have been increased, and there was a tightening of the standards for emissions. There is a potential. Actually, the industry is waiting for some changes, additional changes. They talks about a stage 6 or for non-road machinery, or Euro 7 for road vehicles, starting around 2025, 2026. In North America, the main force driving change for climate zero emissions is the state of California, which put like different programs and initiative to combat smoke forming pollution. And indeed, currently, the California Clean Off-Road Equipment Program that offer vouchers have a budget now of $125 million. At the federal level, the Department of Energy have tightened the environmental standards, and also put money on the table to actually help with decarbonize the domestic transportation sectors and other sectors later on. Globally, there have been several initiatives between government to reduce the pollutions and now reach net zero neutrality by certain dates, and all or most the government worldwide are contributing to this effort. But one of the real drivers that actually speed up and made non-road machinery electrifications a reality and fastened its execution were actually the municipalities, especially in Europe, where several municipalities have developed more aggressive policies to reduce carbon emissions. This is an example of several cities in Norway, where several cities have declared strong targets to cut emissions by specific dates. But they are not the only one. There are actually a lot of cities across Europe and across the world that adopted the same approach and have specific targets, as shown here, for example, in the first in the middle column. But also this municipalities seeing the more and more impact of climate change, they have actually brought in several of these days, or tightened even further. So this tightening of municipal legislations have pushed for more and more usage of electric non-road mobile machinery in different places. When we talk about non-road mobile machinery, there are several categories, but the main categories that were impacted by this legislation are 6. The first one is construction and earth moving equipment. The second one involves the agriculture, farming, forestry machinery. The third section have to do with material handling, basically forklifts and pallet jacks that are used for the transportation and the movement of goods and materials. There is a sector in construction equipment that heavily use what's called as mobile elevated work platform. So that started with scissor lift and then moved to boom lift in this categories. Another part that was impacted was outdoor power equipment, either for municipal or property ground maintenance. It started with commercial, with the residential small machines, but now is actually spreading all over commercial units, and we'll see the reason why. And then the last field that have been impacted is marine applications, especially for those boating and shipping applications that are near shore or inland. But let's look at some of the drivers which differ from one sector to the others that push for electrifying the equipment. In construction equipment, I mean, all these applications have been affected by the regulatory framework, regulatory policies at the government level. But there were more. For example, for construction equipment, there was a lot push to actually move to electric to comply with the noise ordinances and bylaws in the different cities, and to be able to actually work at night in urban settings. There were also a lot of push because these construction equipment, especially the compact one, have been used in renovations of old buildings. This is especially true for Europe, where a lot of buildings were kept with their historical exterior, but the interior is completely renovated. So, which required getting excavators, loaders, diggers, etc., inside the buildings to do the work. So with like if it was combustion engine, it wasn't suitable for this type of applications. When we look at the outdoor power equipment, this is for cutting grass or mowing lawns in municipal and residential places. One of the like drivers for this was the reducing the noise. In fact, this equipment are widely used in municipalities, near offices, in hospitals, in hospital grounds, in university campuses where people are studying, and it was a problem actually mowing these different grass and grounds during daytime. But with a silenced system, it becomes really easy. Another factor that actually drove electrification of this type of machines is the operator comfort and health. Indeed, in Europe, there are legislation that limit the level of vibration, like I'm talking here, mechanical vibration, that the operator is subject, to the point where people operating this type of machines in Europe were limited to only working a few hours a day by legislation. Moving to electric with way lower vibration rate have enabled actually extended operating time for people, because the machine is more comfortable. In the agriculture, farming and forestry field, also electrification is ongoing with because of the legislation, but there are other factors, especially in Europe and in Europe, where many of the farms actually produce their own electricity. So they generate electricity by using byproducts from cattle or from crop that is used to generate their own electricity. So moving to electric machines allow them to actually use the electricity they produce without having to buy diesel and lower their operating costs. In material handling, the usage of electric is widespread now, and the percentage actually of the electric machine is getting to the maybe 80% and even more. And one of the main drivers actually for this, for electrifying even the machines that are used outdoors, is that the users of these machines, meaning the warehouses, the logistics companies, the stores, want to reduce their global carbon footprint to fulfill their social responsibility, which put pressure on OEMs that produce this machine to come up with electric and clean versions for them. So you can see the legislation is driving certain changes, but when you look at specific field, you can see there is additional drivers that are pushing for more electrification and faster electrification. Everyone's agreed that at some point in the future, all the combustion engine will be phased out in favor of electrical machines, but the timing differs from industry to the industry depending on the drivers available. Moving to electrifications enables additional benefits. The machine doesn't require much maintenance. There is no oil change, there is no gas filling, there is no spark plugs, there is no filters to change. So that increases the uptime, and then the operator now spends more time on revenue producing activities rather than maintaining the machine. There is enhanced safety and comfort due to removal of exposure to carbon dioxides and nitrogen oxides, and also lower vibration and noise on those machines, so which increase the comfort and the health standards for the operator of these machines and the people working around that environment. There is noise reduction, which allowed companies, especially in construction, to be able to conduct construction at night time. So currently with the combustion engine machines, the noise is so high that in many places they are not allowed to work at night. With that, also with the usage of the electric machines, definitely the operating cost of the machine is greatly reduced. There are no more motor maintenance. The efficiency of the machine is much higher. There is no idling. There is no waste of energy because of idling and because of the transformation of the energy. And the electricity relatively is lower cost to comparative alternatives such as burning diesel or propane or different things. So that reduced the operating cost, and overall, in most cases, it reduced the total cost of ownership, even with a higher acquisition cost initially. So over a few years, this gets amortized quickly, and the customers start actually reaping the benefit of lower costs. And finally, this enabled to actually meet the regulations and the social responsibilities of all these companies involved in this in using these machines. So with that, like that, we understand the context actually of electrification. It pushed during this period starting in 2019 to actually convert compact equipment, compact electric vehicles and machinery, which brought the need to charge this bigger battery. Now these machines are not anymore a small mower or a little golf car, but now they are bigger machinery. They are compact size. They are 1 ton or 3 ton excavators, which requires a lot of power. So which brought the need for chargers and especially onboard charging solutions. Most applications now are lithium ion based batteries, and which allows also another factor, which allows fast charging of the systems. Now the power requirement have significantly increased. They went from 300 watt to 1,000 watt now to requiring 2 to 11 kilowatt of charging power. The voltages have been kept low, still in the low levels, with ranges from 48 volts to 120 volts. But now, using lithium-ion batteries, there was a need to communicate for the charger to communicate with the battery pack, with the battery management system on the battery pack via CAN bus. With the high demand of power, there was a need to actually now shifting from the traditional residential plug to using either industrial power outlets or using EV charging stations known as AVSEs, even in the context of off-road machinery, of construction sites, especially anything in an outdoor setting, is leaning towards using EV charging stations. These machines are very compact. So if we put an additional charger there, it needs to be very small in size. It needs to be very ruggedized and reliable to be able to withstand the high level of vibration and shock and the extreme temperatures, and also the presence of liquids, of dirt in this environment, and be able to survive for several years in this environment. The charge quality is important to actually make sure that the battery lasts very long and it's used to its maximal performance. The machines now are becoming more and more complex, which required a high level of machine integration and support into customizing the charging solution for specific applications. The regulatory approvals also are needed. These machines are subject to several standards in different jurisdictions, and they need to meet these requirements. And finally, this being a more and more sophisticated equipment, it requires a high level of manufacturing scale and quality standards. Knowing this, our company have looked at this transformation and of this market, and we went to the drawing board, and we start looking at a newer solution to actually fit with this evolving requirements. And that's what brought us to an innovative charging solutions called the XV3300 that involve a 3-in-1. By 3-in-1, what we mean is that the charger has, of course, a charger, a 3.3 kilowatt high power charger. In addition to that, there is a DC-DC converter that provide for auxiliary loads at 12 volts on the machine. And this charger is able to interface with smart AV charging stations to get the power. And that's a new platform that we started developing over the last 2 to 3 years called the XV3300. So what are some of the key benefits of this? First of all, there is a reduction in the volume of this solution, because we are combining multiple components, multiple functions into one. So you don't need a DC-DC separate from the AC charger and another interface to the EV charging stations. All of them are one, which reduces the size, the complexity, but also the cabling and the harnesses necessary to interconnect all this equipment. As mentioned, this type of solutions allow to connecting to standard EV charging stations, which are a very good solution for charging outdoors. With the high power, and also in certain applications, the voltages is actually at the 96 level or 100 volt level. There is even more needs for enhanced protection, such as short circuits, because you have such a large batteries, or over voltage, or over temperature, or under temperature protection to ensure a reliable and safe operation. In this bigger machine that are used in construction sites and are used mining, and they are used in a very tough and challenging environment, there was a need for the product to be actually completely sealed and ruggedized. So we opted for IP67 rated, which provide a high level of protection against liquids, against dust, against contaminant in the environment. And even at IP67, I can actually take the charger and immerse it in water, and still it will continue operating and without any problems. And this product have, like the chargers needs for this market, have to survive several years, up like to maybe 5-8 years in the field, because of these machines have a long expected lifetime. Additional benefit is the offering a DC-DC converter, 500 watt DC-DC converter to power the auxiliary load. So traditionally, a lot of these machines were using lower voltages, and they have mechanical safety and systems without a lot of sophistication. But in the bigger machines, There are lighting, there are signaling, there are a lot of computers on board, the vehicle controllers, and the fans, blowers, heating for the operators, etc., which require a larger size of auxiliary load that are generally powered by 12 volts. So this product will allow up to 500 watt or 37 amps of power to be provided to the machine. The charger is also smart and can enable to allow both the communication with the vehicle to get the status and of the charging and different parameters, and also to communicate with the battery pack to ensure the maximum performance and enable BMS, what's called battery management system, controlled charging. As was mentioned before, the regulatory approvals are very important. Regulatory approvals in terms of safety and electrical emission standards, but also in terms of efficiency. And there are standards with that. This also product needs to be very flexible to be able to adapt to different platform, different requirements, and different type of usage, and via easy software changes to the product to adapt it to different situations. Let's have a closer look to the product. So the XV3300 is available in 3 voltage options. The first one is 58.8 volts, which allow the product to be touch safe, meaning all the voltages stays below 60 volt at all time, and that's what's considered a voltage class A. And the product can provide up to 65 amp of charging power. There is another version for batteries that have higher charging voltage, going up to 61 or 62, and also lead acid batteries, where we push that limit slightly above 60 volt to 65 volt, and still provide 65 amp of charging power. And also in some machines, they use higher voltage powertrains at 80 volt or 96 volt nominal typically, and in which case the charger is able to deliver 40 amp of charging power. From the feature that we include in this charger is as I mentioned before, a 500 watt DC-DC converter, which provide up to 37 amps to the application where it's used. And I will mention this later, but if you use multiple chargers in parallel, you could also parallel the power to get maybe 1,000 watt or 1,500 watt of auxiliary power to the applications for the bigger machines. The mechanical size have to be very compact. As you can see, this product is about 300 millimeters by 204 by 110 millimeters, so which give it a volume just a little bit above 6 liters, which is actually quite compact, and it uses standard off-the-shelf connectors. It's all connectorized, and is IP67 and IP66, both of them for protection against liquids, dust, and even immersion in water. So we have developed this 3.3 kilowatt block, but several applications would require actually have bigger battery packs and require even more hard charging. So we have developed what's called stackable software that allows to use multiple chargers in parallel to deliver powers from 3.3 to 10 kilowatt. That's scalable power. This allows and the charger are available in their blocks, which allows for mounting flexibility. Not all the chargers have to be in one place. They could be distributed in the vehicle wherever there is an opening, but virtually they appear as a big charger to the system and to the BMS. These systems also enable to connect to standard AV charging stations, either in North America or Europe, using standard connectors, and the charger will take care of the communications and the safety with communication with the charging station. Regulatory compliance is very important in these applications. So depending on the country, depending on the region, there are several safety and electrical emissions standards that are required for the different applications, as well as power efficiency standards. So for this is a few examples of this. So in North America, the product have to comply with CSA and the US UL. In Europe, it need to have the CE mark, and because these machines sometimes they get connected to residential network, the electrical emissions in terms of conducted and emitted electromagnetic interference have to be reduced to a residential level, or what's known as Class B. It's not anymore like just connected to industrial grids. These products are used in mobile machinery, but they are also used for low-speed electric vehicles, road vehicles, in which case there is a requirement to actually have this product comply with what's called UNCE R10 legislation. The product is sealed and is suitable for global grids and global usage. The ruggedness of and the reliability of the product is very important in this field, especially this is like the product gets used in a very harsh environmental conditions. So the shock and vibration are very high, and they are even much higher than in road applications, because these vehicles typically are unsprung, and the grounds where they are used are often very rigid, and they don't have actually many applications don't have even rubber tires. They have solid tires, so which produce a very high level of shock and vibration. Electric EMC, electric and magnetic susceptibility is important, because there are other devices on the machine. The temperatures, because these machines are used outdoor and indoor, there is a very high range of temperatures, humidity, corrosion, and contaminants that are present in these environments. And to this product, actually, we do what's called HALT test, which is highly accelerated lifetime testing, to simulate an extended life and ensure that the product is suitable for a long extended life up to 8 years. The charge quality is important for the battery. And a couple of years ago, DeltaQ have initiated a program called Charge by DeltaQ. Charge by DeltaQ is a marking that can be put on the battery, and that will tell the OEM, if they choose to actually use the DeltaQ chargers with the battery, with a specific battery, that they have the right choice, ensuring that the best performance of the battery are guaranteed by chargers. So we partner with leading battery companies to test and validate compatibility with DeltaQ chargers and charging algorithm. And we have a growing list of companies that are subscribing to this program. And in this slide, we only present like a few of these companies. So that was the rationale for this newer platform that combine multiple functions for an onboard chargers, that is low voltage, high power, and applications. But the pressure is continuing on the industry. In fact, governments worldwide continue to commit policies to achieving net zero emissions. And this is a map that presents somewhat a snapshot of where the different governments in the world they stand in terms of actually committing to reach net zero emissions. And you can see the ranges actually goes from 2030 in certain countries up to 2070. But you see most countries in the world have committed to certain target. This will put pressure to actually electrify even more machines. So in the next, and it's starting actually right now, and in the next few years, we are seeing actually a push for more electrifications into the no-road machineries that will go to actually mid-size and large equipment. And for this, the charging voltages actually need to get higher to the 350 to 800 volt levels. The charging, because now this is a much heavier duty machines, the battery packs are much bigger, so which require a higher power needed for either AC charging typically with onboard chargers reaching 11 to 50 kilowatts, and also being able to do DC fast chargings with rates from 20 to 305 to 350 kilowatts. They need to actually, the charging systems need to interface to EV charging stations, either with AC or DC. The chargers need to be compact and high power efficiency. Now the powers are actually very high, that the power conversion is very high. Of course, this product needs to be highly ruggedized and reliable, even more than before, and they need to meet regulatory standards. And of course, these machines are very complex, and the OEMs have a high requirement for product and manufacturing quality. A little bit about Delta Q technologies. We are a part of the Zappi group, which is based in Italy, and it started actually in the 1970s, and nowadays is more than €500 million in sales across different companies. The group have 7 companies that develop most part of an electric powertrains at different power levels. So the group have motor controllers, motors, chargers, navigation software, and a variety of components to enable electrification. The only part that the group does not get involved is actually battery manufacturer, where it partners with various battery OEMs. At Delta Q, we have a vision called Charge the Futures, where we are driven by the promise of an all-electric drive world. We strive to be the supplier of choice to customers in key electrification growth markets, enabling success and positive impact on the environment. Then we try to connect our vision with the customer to enable them to fulfill their social responsibilities, and also becoming their supplier of choice on a global level for quality of product and scalability. Delta Q charging solutions spans from as low as 350 watts all the way to 10 kilowatts, either using single monolithic blocks or parallel chargers. And we typically have charging voltages from 24 to 48 to 80 volt and 96 volt. And this is just a summary to show the span of the different products that the company provide. I'm very pleased to announce that the product that was announced last year is now in full production. The XV3300 platform is now in full production, and if you need more information or need to purchase the product, here is an email, or you can contact the Delta Q sales representative in your regions. To summarize these presentations, we have covered several topics. The vehicle electrification, and here is the key points. Vehicle electrification's innovation dates back from the 1830s, but it's only in the last 3 decades where it reached mainstream. Definitely in the automotive world, but also we saw a large electrifications for indoor and light duty motive and industrial vehicles. This required the use of low voltage chargers below 120 volts, low power, typically below 1200 watts. We saw the emergence, like the predominance of high frequency chargers, and these chargers are rugged and sealed. Starting in 2019, the non-road machinery, mobile machinery emissions reduction legislation was start being effective, and which drove the large electrification of compact vehicle machines. With that, there was a need for higher power, still low voltage, but higher power, especially to charge lithium applications. This required a specifically designed charger for this harsh onboard environment, and also it saw the combining multiple functions in the charger, such as charging, DC-DC conversion, interface with charging machines, with the charger being CAN enabled. The net zero emissions policies and standards continue to evolve, and which are driving and pushing for even more electrification with in the future, in the near future, with mid and large mobile machinery. To support this electrification, it needs higher voltage chargers going from 400 to 800 volts, higher onboard power, onboard charging power from 11 to 50 kilowatts, or offboard DC fast charging from 20 to 350 kilowatts. The products, the chargers need to be compact, highly ruggedized and reliable, and interface with EV charging stations, including both AC and DC charging support. And with this and the presentations, and we open the floor for questions.
Yes, if you would like to submit your questions, please use the chat function to submit them, and we will be going around answering them in the last 15 minutes of this presentation. So Mourad, we already have a few. One question that we have is, with regards to regulatory compliance, what would be needed to consider using the XV3300 as part of a portable charger, not built into an automotive unit, but as a standalone portable system, mostly considering FCC Part 15AC conducted emissions in this context?
Yes, thank you for the question. The product actually already comply with either using the product on board or off board. As a matter of fact, we have several leads that we are working on that will be using actually the product off board. So the charger complies with what is Class B emission, which is actually suitable for connecting to residential grid. And then yes, it complies with the standards mentioned for off-board applications. One additional thing is actually in North America, the chargers used off-board by themselves need to have a higher level of certification, which actually are UL, they have to be UL listed. Most components actually, when they are integrated in the machine, are UL recognized, but for off-board applications in North America, it requires to have UL listing.
Perfect. So the next question is also similar to the previous one, is when you are paralleling units, is this possible in a portable unit while considering UL FCC standards? They're thinking around ground fault current or AC emissions again.
Yes, yes, actually, yes. The product has a very low leakage currents, so which will allow it to actually comply with the ground fault requirements. So, for example, when you are using two chargers or two chargers, it's below, like the combination of both of them are below 5 milliamps. So yeah, it will require, and then definitely with 3 chargers, they are below 20 milliamps. So that is fine. Now, when you put the systems together, all together, so the charger by itself, its charger comply with the EMC standards, but if you put them together, there may be a little bit more higher. So it depends on the systems, but there are mitigation strategies on adding a little bit of external filtering to comply with the regulatory standards.
Awesome. So then another question we just received is, on the slide of EVSE support, you show a DC charging station. Does the XV3300 act as an interface for DC charging?
Not at this point. No, it doesn't. And I tell you the reason why it doesn't. Currently, all the DC charging stations, they provide voltages starting from 200 volt DC and up. So they are typically 400 volt DC charging, which is actually available in most cars. And now even the standard is evolving. Well, actually not the standard already covered that, but the charging stations have now actually can enable charging up to 800 volts. But at the lower level, they are limited to 200 volts. So if you have a system with 48 volt or 120 volt, DC charging will not work. So at the compact level, at the 48 or 96 volt levels, you cannot charge the vehicle from a DC charging station. When chargers have a higher voltage, for example 400 and 800 volts, yes, at that point DC charging and supporting AVSEs with DC charging and the communication is necessary. But at the 48 volt and 96 volts, this is not needed, and actually it won't work because the voltage levels are different.
Awesome. So another question that we have is, what is the EMC ratings, 10 volts per meter, 30 volts per meter, etc.? And will there be an EMC hardened version?
This is a very complex questions that maybe we can take it offline. So if you can send us actually this by email, this requirement, we'll be more than happy to actually answer these questions.
Perfect. How does putting chargers in parallel affect EMC radiated emission testing?
The EMC could be slightly higher, but the EMC profiles are highly dependent on how you place the chargers, about the harnesses that are used, and especially about the grounding of the vehicles and the different elements on that. So it's highly a complex issue that is not like straightforward. It's not that you add 3 of them and it's 3 times higher or vice versa. So it's a complex thing. So depending on how it's structured, it could pass the requirement, or there may be a need for adding some EMC mitigations outside chargers with filters, with beads, or with toroids, or even inline filtering.
So for the version with EVSE, does this have a dedicated circuit to keep the auxiliary 12-volt battery charged?
Yes. So that's actually what we have, the DC-DC charger. The DC-DC chargers will provide the power to charge the 12-volt battery. So in all applications requiring interface with EVSE, the system should have a auxiliary power source, typically a small 12-volt battery, and the DC-DC will provide the power to actually keep that battery chargers, either when it's charging from the AC source, or when it's operating, and it will be charged actually from the traction battery.
Awesome. So another question is that, will it be possible to have both connection types on a machine for a worldwide product, or will we need to choose based on the market the unit is sold?
There are some slight, so the charger itself will work with both both standards in Europe and North America. But there is a slight difference in operation, which require that loading a different software. So the machine, like the signaling, everything, will be the same, but it requires a different software to be loaded in the charger that could be done by the customer or at the factory with two different chargers loaded with different software. But the hardware itself, it's exactly the same, and the charger is compatible with both. But on the machine level, it will be, it's nobody have done it before to actually have the machine with the two type of connectors. So when you have the machine, you will have one type of outlet or inlet that is suitable for either G1772 or mode 2 and mode 3 in Europe. So the machine will be different, but the charger itself, from an electrical point of view and signal point of view, support both standards. The software, because the operation is slightly different, need to be loaded for the appropriate region.
Awesome. So another question that we just had is a 500 watt DC output designed to charge a 12-volt battery? Meaning, is a DC-DC smart enough to lower the output voltage if current draw is too high?
Yes. So the way so that's like it's smart and adjust the output voltage based on the current draw. So for example, if there is a severely or a discharged 12-volt battery which draws, the voltage will go down to the maximum of 500 watt or to 37 amps. So yes, it does adjust, and after that it keeps it floating at a certain level. There is additionally possibility, actually, if the customer, it becomes a little bit more complex, but the system could adjust that via CAN bus. So that level of floating voltage could be adjusted via CAN bus. But generally, it's just keeping it floating. The voltage will drop when the battery is discharged, and then will grow until it reach the maximum value, either being 13.5 or 13.7 volts.
Awesome. So another question that we have is, will you be making the charger compatible with EMC requirements such as 100 volts per meter immunity?
Yeah, so that's this question. We'll take it offline. So please reach out to us via email, and then we'll be happy to answer that question because it requires some investigation on those requirements.
Awesome. So another question that we have, and this will be the last one as we are running out of time. Any other questions that we weren't able to answer, we will email you separately and privately. And we will also be able to answer any other questions that you have if we weren't able to answer them today on the info@deltaq.com, which will be monitored by myself and Mourad. So if you have any questions specifically related to the charger or anything else, we'll be happy to answer that. So this question is, with the anticipated take-up of electrical charging globally, how will the charger cope with low voltages on the network, which has not been built for additional loadings? Will the charger ramp down in output if the voltage drops, or will they turn off?
Well, the charger itself has a very wide range. So it goes from 85 volts, as low as 85 volts, to 220 to 265 volts. So it's a very wide range. Yeah, and the charger is smart enough, so when it sees a drop, or like if there is a drop of the voltage, it will limit its output to still provide the maximum current capable, but still limit the input current to not to trigger the breakers and the safety in the system. So the charger will operate all the way up to 85 volt there, but the output power may be slightly derated if that happens.
Perfect. Well, that's all that we have for today. Thank you so much for all of the wonderful questions. Like I mentioned again, if you have any other additional questions, please send it to info@delta-q.com. Myself and Mourad will be monitoring that email, and we hope you enjoy the rest of your morning, afternoon, or evening. Thank you.
Thank you. Bye-bye.